Swayam Prabha. Digital India. Educated India.
Welcome scholars for attending our course on health economics as part of the NPTEL. Here we are discussing the important aspect of behavioral economics chapters on specifically on prospect theory. I am just recapping what we did and what we are targeting to do. We started the basics of behavioral economics in the previous lecture, and here we will discuss more on prospect theory, initially developed by Kahneman and Tversky in 1979. We will also emphasize the problems with the expected theory and the origin of this, and their framing, certainty, reflection, loss aversion effects, and we'll talk about editing and evaluation phases in choice process. And we will also emphasize the discussion on value and weighting functions, and also we will discuss endowment and status quo biases as attached with the existing theories. So, considering the work of Kahneman and Amos Tversky on the aspect called prospect theory. I mean, both of them introduced the prospect theory in 1979, and their famous paper was called Prospect Theory and Analysis of Decision Under Risk, and it is also known as loss aversion theory, because it points out that the fear of loss is greater than the satisfaction from profit. Okay. So, this theory critiques the EUT, that is expected utility theory, which provides an alternative model and accounts for bounded rationality by relaxing the assumption of complete transitivity and independent preferences, which we used to take in the EUT theory or the expected utility theory. Choices among risky prospects exhibit several pervasive effects inconsistent with utility theory's basic principles. Prospect theory in psychology suggests that people will think about gains and losses and prioritize the potential value of losses and gains rather than the potential outcome while choosing from the possible alternatives. We are just comparing here the EUT and the PT, prospect theory and the expected utility theory, and we mentioned already that the EUT is based on the rationality assumption, and the rationality is again bounded as mentioned by Kahneman and Tversky. And bounded rationality, that means that people with cognitive limitations and unable to make decisions consistent with completeness, transitivity and independence, and that is actually discussed in the previous lecture. And coming to the prospect theory, that's mentions that irrational human behavior influenced by various biases like risk averse and risk seeking behavior even at the same time as well. Three main biases are noted while understanding the PT or the prospect theory. They are called certainty, reflection and loss aversion. Even to count the contribution of this theory, Daniel Kahneman and received the Nobel Prize in 2002. Unfortunately, Tversky passed away before 2002 and couldn't win the prize. So, then what is a prospect? Prospect is caring with the probabilities with the choice function, and is indeed prospect is indeed a contract that yields outcome xi with probability pi, whereas the sum of the pi should be equal to 1. Then the prospect theory, where the extent of risk is explained, then what is a riskless prospect? To be explained. What is called riskless? A prospect that yields x with certainty, and donated by only x, whereas the risk prospect and the decision making under risk can be viewed as a selection of or selection between prospects or gambles or lotteries. So, prospect theories are actually presented through the valuation functions, how people actually value their contracts or the prospects. So, it is exactly mentioned as maybe for a lottery L, the value of L is equal to the value of those possible outcomes with their probabilities. Okay. So, if people are rational, then their valuation function, that is V, must follow the basic mathematical properties such as completeness, transitivity and independence. So, completeness, as I told you, it largely emphasizes the or clarifies the extent of independent decisions, and and that's basically when A is preferred to B, or similarly B is also preferred to A, when a combination of prospect with their value or the value function which combines the prospects of A is preferred to A, or the value of the prospect of B over A, that means these two are actually independent. That is called completeness of preferences. Transitivity I think need not be clarified, and so far as independence is concerned, once any prospect and the valuation is preferred, their combination is also preferred over or the expected value of those is also preferred over the other basket of choices. So, this is largely called the valuation function, and the valuation function under expected utility theory, this is what is presented to you. So, Neumann and Morgenstern proved that only one functional form for V satisfy all three properties which we have just mentioned now, properties like completeness, transitivity and independence. This valuation function which we have just said, B is a function of this combination of or function of their individual outcomes with their respective probabilities. When we share these and this through the typical Neumann and Morgenstern approach of presenting the expected utility theorem, this valuation function is also known as von Neumann-Morgenstern utility function. This valuation equation is the statistical definition of expected utility of all outcomes from lottery A, the theory that people make decisions on uncertainty based on this particular valuation function in the expected utility theory, which I already discussed. Coming to some of the evidence that people make choices that contradicts the UET, which we already started discussing in the last lecture. Here we are actually discussing the contradictions based on the possible prospects. We will also clarify each of them with some examples, starting with misjudging probabilities, then framing, then loss aversion. Then within misjudging probability, there are two, maybe overvaluing certainty, that means certainty effect is noted, or overhauling small probabilities. I will clarify it just now. Other category in the case of loss aversion, there are endowment effect and the importance reference points will clarify. Starting with the overhauling certainty, which we have just said. Okay. Right. So, overvaluing certainty, yes, overvaluing certainty where the irrational decision might or irrational decision making might be due to misestimate probability of risk. KNT or Kahneman and Tversky show that even if true probabilities are known, people's stated preference violates rationality. Overvaluing certainty, where people may overweight outcomes that are certain to uncertain outcomes. Okay, so I'll give you the example as well, like in the two cases when the certainty is there, but the expected outcome is even higher than that, but still people prefer the certainty ones. So that has actually indication of certainty effect. Best known counterexample to expected utility theory which explore the certainty effects, as we mentioned for the case of Elias 1953 example. We can also revisit and explain. You can just see here, this is where we are going to explain the Elias paradox as well. Kahneman and Tversky discuss variations of Elias example to explain the certainty effect. So, here in the problem 1 there are two case. One is in the case A, you will see 2500 is the outcome with the probability of 0.33, and another 2400 outcome with the probability of 0.66, and 0 with probability 0.01. Whereas in the case B we have 2400 certainty, or the outcome with certainty is 2400. It has been observed that out of 72 people who took this question, only 18% choose option A, while the 82% actually choose B because of this certainty. You can just see what really happens so far as the expected utility is concerned. On the first case, that is case A, it is the expected utility is even higher, that is 2409, which is higher than that of the case B, but in the case B it has certainty indications, that is with no probabilities, or the probability is 1. Okay. But because of certainty effect, the preference is higher for the case B. This means that the valuation for A is actually lesser than that the valuation for B by the people, okay, even if the expected utility is different. Now we are presenting another case 2. Case 1 we have already said 82% choose option B. Okay, now we are actually presenting case 2, presenting another problem where both the cases are attached with certain probabilities. So far as the return is concerned, in the case C you will find 2500 with probability 0.3, whereas in the case D it is 2400 with probability 0.34. Okay. So, however, if you just check this, out of the 72 people, 83% actually choose option C, okay, as against only 70% for D. So, we will just calculate the valuation function based on the Tversky and Kahneman. You will see what really happens in the problem 1 case. We have already mentioned the valuation is higher for the case B. This is what we mentioned, and whereas in problem 2 just the reverse is noted. Even if the respective utility ratio are same in both the case, but choices are different, just the reverse. Okay. And here the C is preferred with less probability, okay, and as against D. But you just see what happens when we take, I mean just we need to note that throughout this chapter we assume that the utility function, you need to first note that utility function is actually normalized throughout, otherwise it is difficult to compare different context. And since utility is a relative concept, and that means superior outcomes offer more utility than the inferior ones regardless of their absolute level. Now, from this example, this and this, what we have seen that the expected utility functions may not accurately describe how people value lotteries with uncertain outcomes. Okay, so with uncertain outcome, people are actually highly confused, and their views are not actually signaling how in generality or in general context the reverse preference are taken. So this is how is actually called called partly discussed for case A is even if this is higher than this is greater and this is lesser, but the choices are actually different. This is precisely called Eli's paradox. Here in problem 2, another two problems we are just citing for your reference. We are just mentioning, you can calculate and explain. These kind of questions might be there in your assignment. So I am just keeping you for you to go through. However, I am just giving you directions. Kahneman and Tversky attributed this flaw in EUT to the certainty effect, okay, which you have started explaining. That means the people have the have a certain rigidity, in their mind to go for the outcome which has certain degree of certainty. Okay. The failure of EUT implies that people seem to be using a valuation function other than the expected utility function as proposed by Neyman and Morgenstern. So we have already mentioned these details in the previous lecture as well, that as per the problem 3 and problem 4, you can just see I am not explaining much. We have already said that this violates EUT. You can try on your own. Okay. So coming to problem number 5, another case where the case of overvaluing small probabilities. That is very interesting to note. Identified rightly by those authors as part of the explanation of prospect theory. They compare with what is called the actual probabilities as against the perceived probabilities. There are some tendency of the people to perceive the probability differently. Okay, like when we have zero probability. Okay, you see like in this example 5,000 with probability 0.001, that means the outcome is with a certainty is there, but the probability is very less, and 0 with the probability with surety is there, that is 0.999. You are going to get a 0 outcome, that means you are going to get an outcome with higher probability. Another as against another case is like 5 with certainty. People choose largely with case A or the option A, that is 7 to 1, only because of the fact that this has guarantee, this has given a higher guarantee with very small probabilities. Okay. So when the actual probabilities are close to 0, you can just see from the 45-degree line. When actual probability is very close to 0, people actually do not put it as 0. People say that yes, it has a higher probability, because when it is 0, they as if the probabilities will be very less and surety is there, they take the risk. Okay. So people seem to systematically overweight very low probabilities and underweight medium or large probability. Once it extend certain level of probabilities, they started giving higher value. Okay, or giving underweight, overweight the lower probabilities and underweight the medium and large. Therefore, this diagram is actually clarifying the difference. At the 0 level it is higher, and in other level you will feel the difference. One typical example is given in the context of the person who used to smoke. Okay, the chances of smoking and its outcome is expected to be catastrophic, but those who are just started or at the beginner level or just taking very few time frequency of smoking, they usually overestimate the probability of this event to happen or the mortality or the risk. Okay, so maybe at the start, those who are starting with this or the light smoker overestimate their mortality risk, whereas the heavy smoker, once they are habituated, they know they in between they might have derived certain perceived understanding this. Since this is not creating any trouble, therefore they also predict that with heavy smoking it's not going to create any problem. Hence heavy smokers underestimate their risk. This is another example I think you can apply in our work. Okay, so this was referred to the Kahneman and Tversky, the original writing in 1979, differentiating perceived probability and actual probabilities. This is precisely called overvaluing small probabilities. Another is called framing. In expected utility theory, final outcomes are all that matters. What frame you make, finally what you get really matters. In prospect theory, however, it is presented little differently. It is presented as how a final state is reached that really matters. I mean, state and the process really matters. Like in EUT, expected utility theory, if you are given $50 directly or first given $100 then taken back $50, both ways gives equal utility. In this framework, these two situations are actually equivalent, whereas in case of prospect theory, these are not the same. Framing of a problem can affect the perception of how valuable each choice. Giving and taking are not the same activities, or the not having the same choice function or the preference function so far as prospect theory is concerned. One is called to explain this, it is called isolation effect. How far the things which you have already perceived, already possess, getting isolated from you, you might give higher importance to that possession. Different decompositions of a pair of prospects into common and unique components can result in varied preferences. This phenomenon known as isolation effect. This highlights how diverse decomposition may yield different outcomes. The isolation effect implies that the contingent certainty of the fixed return enhances the attractiveness of this option relative to a risky venture with the same probability and outcome. So, this occurs, isolation effect occurs when people have presented two options with the same outcome, but different routes to outcome is important. In this case, people are likely to cancel out similar information to lighten the cognitive load, and their conclusions will vary depending upon the options they have been framed. So, others are like representation, whether it is through a standard representation or through a sequential representation. We are presenting here through a problem. Here is a problem called problem 4 through a two-stage game. Okay. So, first stage with a probability is 0.75 to end the game without winning and anything, and the probability is 1/4 or 0.25 to move to the second stage. If it is there in this, it has a sequence, if sequence follows with other probability, like in the second stage we have probability 8 to win 4,000 or 0 with 20% probability, or there are two sequence, first one is this, then second one is win 3,000 with certainty. In this two stage game, winning 4,000 has, what is the probability then? You can just see in the first stage, second stage we started with backward counting like 4,000 with 0.8 probabilities. Since the person has opted for the second stage, that means person might have taken the game, okay, must have entered the first game. Probability to end the game without winning, that means 0.75, person has actually closed in the first case. So, the person has entered to the second stage with the probability of this, that means this has to be taken. So, this is included 0.25 times 0.8, so 0.8 is here. So, the joint probability is actually 20% to win 4,000, okay, and to win 3,000 again 0.25 is there, and the second stage it does not have any probability. So, that means 0.25 times 3,000, okay. So, I mean sorry times second one is 0.25, second times second stage it has probability 1. Okay. So 0.25 times 1 to get that 3000. Hence, for the second case the probability is 0.25. This shows how choices may be altered by varying representation of their probabilities. Here we are just presenting the sequential aspects. How it follows, you can just see the nodes are presenting differently. This gives direct possibilities to the second phase, whereas this has a choice function. Okay. In the first one, again, to get 3000 as the outcome, you have 1/4 probabilities, and you have 3/4 probabilities or 0.75 probability to get 0 as the outcome. Okay. And whereas in another case you have 1/5 probability, that is 20% probability to get 4000, and 4/5 is 0. So decision makers face a choice between these two risk prospects. Two prospects are independent to each other. In problem 4, most people choose 20% probability to get 4000 at the as the outcome, because it is very clearly paying more, because this is the one, whereas 25% probabilities to get 3000 is not the one, rather this is preferred than that of this. Okay. Okay, coming to the sequential formulation in another form is how, if 1/4, I mean there are two stages. This is actually with surety 3000 is received in the second stage. That means 1/4 times 1 to get this, or to this is in any case is not obtained, since 0 is the outcome. So, one is actually following this. If this is the case, again in the second stage, this time 1/4 times this for to get this, and or 1/4 times 1/4 to get this. So, by comparing all these possibilities, one will reach at the conclusion. So, two prospects are in this case, two prospects are actually dependent. Alright. So, decision maker face a choice between risky and riskless prospect, and two prospects are actually dependent because the probabilities on the first and the second are actually dependent to each other. So, yes, certainty advantage is there in case of choice function. So, they choose 3000 with certainty, and then we have also presented in our previous case about how certainty is considered to be usually preferred. So, another aspect is called loss aversion. So far as we assume people are either less risk averse or less seeking or neutral. Actually they are both at the same time. They might be risk averse as well as they might be risk seeking. Alright. So, it has a link with their endowment, and it has link with their status quo. Okay. So, if it connects to the endowment, the tendency of people to attach greater value to a loss of a given amount than to an equivalent gain. If they are losing something, actually they give more, because they have an endowment effect, they have already been attached with that product. So, if you are giving equivalent amount to that, still people may not give more weightage. Status quo, where effect it suggests that a tendency of people to prefer the current situation and to be resistant to the change. So, whatever was there, they already perceived, already reached, they prefer to reach that level only. That is part of status quo. Reference points are necessary to discuss utility gains and losses, as outcomes may differ with change in reference points. Of course, it matters where you start. Okay. So, the way how it is presented is or represented matters. Okay. So, either there are two ways of presenting the prospects. One is called positive prospect and negative prospect. Like if you present the persons to with their positive effects, they are getting the returns in positive, they are actually preferring the certainty. 80% of the people out of the 95 people in total, they prefer with certainty without any this is probabilities, and probability attached with case A as against case B. So, they prefer more of case B, where positive values are given. If the reverse is just given, that you are supposed to get an outcome with a loss of something as against another loss. Okay, so if another case C and case D is presented, but the presentation is through a loss, then people actually prefer just the reverse. Okay, so it is, you can just compare these as against these. It is just the reverse. All right, so they don't want to actually lose by certainty. Okay, if there are certain amount of losing somewhere, so they are least preferred. Similarly, in other cases you see this one 65% preferred, whereas just the reverse is noted here. Okay, in case of negative prospects, I think I have already discussed, and this is also called a reflection effect. When something is reflected or in a mirror image is presented, but the choice function actually just gets reversed. All right, and the replacement prospects around 0. So, from 0 means from positive or from negative sides. So, we have already discussed this. I think you can go through and find out how some people are both risk averse as well as the risk seeking from the example as well. Coming to the prospect theory in terms of some phases, it is called editing phase or evaluation phase. Hence, decisions are taken accordingly. Okay. Editing phase consists of preliminary analysis of the offered prospects, and this is to organize and reformulate the options so that the prospects are considered to be different and choice are accordingly taken. Usually the marketing guys follow those rules, those strategies to attract the customers. And in evaluation phase, in particular, edited prospects are further evaluated and prospects of highest value is actually chosen. You can see in the editing phase, in the first one they start with further coding of the preferences or the choices or the outcomes, and that individuals view results as gain or losses in relation to reference point, and they make combinations of the prospects for simplification purposes. Like you can see, if this is the probabilities are attached, 25% probabilities to get 200, in another case is the and choice is there. If they combine these two choice, there is a 50% probabilities to get 200. So, combining model is going to be more preferred and accordingly chosen. Similarly, segregation, when we segregate the riskless component in particular from the risky component. Okay, so, like you can see here, these as against this, then this can be decomposed into a simplified versions of segregation called only minimum 100 is actually guaranteed with, at least in both the choices, 80% is there to receive 100 as the outcome, okay, or gain. So, that and in this case, okay. So, what we see, we out of these, the prospect of these two, a case A and case B is decomposed into a sure gain of 200, okay, and the risk prospect is in this case is actually again still there is a risk component is called 100, okay, with 80% probabilities, but for sure 200 is actually is the surety of gain when we segregate them correctly. Another is cancellation, when repetition or the common constitutes are there in the choice function or in the choice basket. So, the common constitutes can be avoided, okay, can be cancelled. All right. So, discarding the common constituent, like this is what we have highlighted in this case. This is for 1, this is just avoided, and we just compare other options, right. So, sequence of editing really matters, and that really helps for a better prospect. So, another is called valuation phase, which we have said evaluation phase. So, that is called evaluation phase, where valuation function is important, and this carries the better weighting functions, okay, of those value function we already started discussing. Valuation function under prospect theory is analogous to the expected utility theory. This differs than that of the UT, because UT function evaluates absolute income only, whereas in PT value function is calculated relative to a reference point, that is more important. Hence, prospect theory's value function evaluates changes in their income as well, health, rather than absolute level of their the states. Therefore, the value function can model loss aversion as well. Okay, so for given value of x, value of this one should be at least less than that of the minus of that level. Okay. So, the value function is presented in this illustration. We just see that it follows in the positive part, it follows a convex function, it follows a convex, I mean in the positive side, second derivative, since it is going to be negative, so it follows a concave function, whereas in the negative side of it, or in the other side of the value, we have a convex function. Alright, so because of this, and you will see one another interesting aspect, that when the negative side of it is being evaluated, you see the changes are very sharp, okay, and the value function is therefore for the losses is steeper than that of the value function of the gains. This is actually more steeper, this downward side is actually more steeper than that of the gain side. There are different characteristics of value functions. I think you may go through in detail. I am not presenting. This follows a S-shaped curve, and this reflects diminishing sensitivity. I have already mentioned how people give different value at different gain as against losses. We have already presented in our diagram positive prospect as against to negative prospect side also. Here also, when you go for the negative addition of something, your diminishing utility is different than that of the rate of diminishing utility of the positive side. So, it does not depend on the wealth level, and solely depends on gains and losses relative to the reference point, which correspond to the origin as well. Similarly, you can see the point of origin that compares with the loss of aversion, we have already discussed. Since we are running short of time, I am not mentioning much, I am just clarifying the basic details. Similarly, in this prospect theory, you will see decision weights, how it matters. Decision weights may look like probabilities. They affect how much each outcome is considered. The decision weight of impossible event is also 0, just like probability, and for certain event its weight is 1. I think these are we have discussed. However, the decision weights diverge from their associated probability, and sum of all decisions do not always add up to 1 and is often less than 1. That is another interesting aspect. Therefore, this property is known as sub-certainty. It is not 100% certainty. This is to be noted, and you might see some of the questions in the assignment or in the final exam. So, you see there are we have to clarify this, you can also cross check. So, the sum of the value and these weights are not necessarily going to be 1 in this case. So, given this example, the value function as presented for the problem 1 and problem 2, you will just see that 82% actually choose option B because of certainty, and in the other C and D case actually more people preferred for C. And this also clarifies from our prospect function that value of B is greater than that of value of A, and in this case problem 2, value of C is greater than that of value function of D. Okay, so you can just see how it is calculated. We have given the steps for each of their probabilities, okay, and accordingly you can find out the total valuation. In the other case also it is defined step by steps. So, this is what we already discussed. Like the endpoint behavior is also important. So, event is guaranteed. So, decision weight is of course 1, and people misperceive very low probabilities, which already discussed, and came in 79 paper discuss all these things in detail. So, one implications of these for health economics is emphasized in the RAND health insurance experiment. You will see that I will just take another 2-3 minutes to wind off that the UT expected utility theorem finds that the families with similar incomes and risk of illness would demand similar level of insurance regardless of what type of coverage they had during the experiment. Okay, RAND experiment also we have discussed in other units. Whereas in case of prospect theory, families who were assigned to have less insurance coverage during the experiment were willing to pay much less than the families with broader insurance coverage for a new insurance plan after the experiment. Okay, it's how these two are actually different. You can just have a check. So, this shows that consumers that gains and loses asymmetrically, not symmetrically. There is some inertia in plan choice. The plans that are held more highly valued than equivalent plans that have not been at all purchased. It has effect of status quo as well as endowment bias. Okay, some other have also discussed this. However, in health insurance and covering only losses case, people makes makes people act risk lobbying. Using prospect theory, the authors explain both over insurance for cars, electronics, and under insurance for health, showing how this theory applies to different type of insurance decisions. So, you can just go through this case and will be interesting for you to read. Okay. So, we have just at the end we want to emphasize one case based in India by those topmost authors. We have cited their work, explanation of how low takeoff of micro insurance in India from behavioral economics. All right, and the prospect theory is largely discussed, and they have cited the case of Yashaswini cooperative farmers healthcare schemes, which is largely self-funded scheme based in Karnataka, India. Prospect theory says that individuals are risk averse towards gains, but least risk loving towards losses. Because health insurance covers losses, individuals should act as risk lover for their demand for health insurance. Similarly, hyperbolic discounters are more willing to buy insurance. I mean, it's not just a linear approach. There are hyperbolic context as well, and that is also noted. So, finally, in the results, it is evidence for the adverse selection, as households with a higher ratio of risk members are more likely to purchase insurance. Behavioral explanation for low offtake is also given. So, even we will discuss these details. So, in addition to that, there are some aspects to be noted called health technology assessment. We have already discussed we are actually discussing in unit number 8 on theory and principles of economic evaluation. We will study the methods to quantify the benefit of medical treatment, such as standard gambles and time trade off. The two methods etc. are discussed, and especially in the author Blecho 2002 explained the disparity between these two, that is standard gambles and the time trade off, emphasizing the probability weighting, loss aversion and scale compatibility. So, they also derived the explanation for expected utility theorem and the prospect theory and its implications. You can just go through, I am sure it will be interesting. Prospect theory also suggests that small interventions or nudges can have outsized effects as well. Some of the things you will find out, especially the status quo effects as part of the RAND HI experiment. Similarly, other aspects like school cafeteria as an example we discussed, and we will also discuss more about nudge theory in our other lecture. Okay, so next lecture in particularly emphasizing on time inconsistency theory of behavioral economics. These are readings for your reference. I hope you will have interest to study, and there are so many things in between. We are just giving you the fundamentals to behavioral economics. That's all for today. Thank you.